Okay, everyone, I'm really sorry. It has been very smooth for the last 3, 4 months during the crash course, but I don't know what has happened now. The rain is messing things up a little. Uh, so we had an electricity issue here, but now we're back. Now it's on again. It happened earlier today as well for 5 minutes. Hopefully, it stays fine now. So what we're gonna do now is we're gonna jump right into the paper so that we don't waste any more time. I've answered this question already, that you should always complete the whole paper before you look at the marking scheme. At the end, you should look at the marking scheme. Once you're done with the whole paper, you should check your answers. That's important so that you can figure out where exactly you're doing mistakes, where you're making errors, so you can correct them. And then if you don't understand something, of course, you should ask about that in class as well. Okay. Okay, so this is the paper that we're starting today, May, June 2023, October, November 2023, paper 1, variant 2. Let's start with. So we've talked about the instructions earlier as well in the first introductory class that we had. The key thing that you need to remember here is the level of accuracy, minimum 3 significant figures in general, when you have non-exact answers, and minimum 1 decimal place when you have answers in degrees. And apart from that, you need to make sure that you show all working clearly, do the paper with a pen, and all the other details. We've talked about that before. Now let's start with our first question. Now remember, this one paper from this session, we're going to complete. We're going to do completely all questions, and then the other two variants, variant 1 and variant 3 from this session, we will be doing only the difficult questions for those papers. I'll be posting polls today where you will be letting me know which questions you found difficult from those two papers. And we will be discussing those specific questions in our tomorrow's class. Okay. All right. So let's begin with this. Question number 1, it says the coefficient of x cubed in the expansion of 3 plus 2ax whole raised to power 5 is 6 times the coefficient of x squared in the expansion of 2 plus ax whole raised to power 6. We need to find the value of the constant a. Now, this is a binomial expansion question, right? So you have this expression and you have another expression, this. You are given that the coefficient of x cubed in the first expansion and the coefficient of x squared in the second expansion, they are somehow related. So what you have to do first is find those two coefficients. Okay, find those two coefficients. Now, this is one way of doing this. One way of doing this is that you just expand both of them. So let's start with the first one, this one. 3 plus 2ax whole raised to power 5. Let's start with the expansion of this. Remember the term that we're looking for in this expansion? That's the x cubed term, right? This is the term that we want from this expansion. Now, remember the formula. It's written in the formula sheet as well, although in a slightly different form. But if you remember this form, it looks like this: a plus b whole raised to power n. That's a raised to power n plus nc1 into a raised to power n minus 1 into b plus nc2 into a raised to power n minus 2 b squared, and so on. This is how this formula goes. Now, what's in place of a in this expansion? In place of a, you've got 3. In place of b, you have 2ax. So you just need to input values in this formula and see what that gives you. A is 3, so that's 3 raised to power 5 plus 5c1 into 3 raised to power 4 into 2ax whole raised to power 1 plus 5c2 into 3 raised to power 3 into 2ax whole raised to power 2, and so on. This is how this expansion is going to work. But what are you looking for? You're not looking for the whole expansion. You are only interested in the coefficient of x cubed. Now, what you can do is you can look at the pattern that you have in this expansion of the powers of x. Look at the powers of x that you have. What's the power of x in the first term? Let me just bring it down a little. What is the power of x in the first term? It's 0. It's a constant, right? What about the second term? 2ax whole raised to power 1. It's x power 1. Now, just by looking at two terms, if you remember, the difference between these powers always remains constant. All right, so in this case, the difference is 1. So the first is 0, the second is 1. We know that the next one is going to be x power 2, and the next one is going to be x power 3. And this is the one that we are looking for. So we need one more term after this. Okay, so let's do one more term. Let's expand one more term. What's the next term that we get after this? The next one is going to be 5c3 into 3 raised to power 2 into 2ax whole raised to power 3. And this is the term that we basically wanted from this expansion. This is the term that has x cubed. Now what you can do is you can just forget about everything else in this expansion and just focus on this last term, because that is all that you're looking for. You want the coefficient of x cubed, and this is the term that we want. You don't have to simplify everything else here, just simplify this particular term. You see what 5c3 gives you? 5c3 is going to be 10. 10 into 3 squared, that's 9. Into 2 cubed, that's 8. So that's 8a cubed into x cubed. What does that simplify to? 90 into 8, that's giving me 720. So this simplifies to 720a cubed x cubed. This is the coefficient of x cubed that we're getting from this first expansion. This is the whole term. The coefficient is going to be just this part, 720a cubed. That's the coefficient of x cubed. Okay. Now we have to look at the second expansion. What's the second expansion? The second expansion is 2 plus ax whole raised to power 6. From this expansion, which term are we looking for? We're looking for the term in x squared, the coefficient of x squared. Let's do that expansion as well now. Let's do the other expansion. So now the other expansion is 2 plus ax whole raised to power 6. What does that give us? Let's just apply that formula. In place of a, we have 2 here. In place of b, we've got a times x. Let's just input values in the formula. What does that give us? 2 raised to power 6 plus 6c1 into 2 raised to power 5 into ax. Now you can just stop here and look at the pattern that you have in these terms as well. Now these are very simple expansions. So in this case as well, the pattern of powers that you've got is x power 0, x power 1. So the next term is going to be x power 2, and that's the one that you're looking for. Just expand one more term. That gives you 6c2 into 2 raised to power 4 into ax whole squared. This is the term that we were looking for. The term in x squared. Let's see what this turns out to be. Let's simplify this one now. What's 6c2? What does 6c2 simplify to? I think that's 15. Let me just confirm that. 6c2, yeah, that's 15. 15 into 2 raised to power 4, that is 16 into a squared x squared. 15 times 16 gives us 240. 240a squared x squared. This is the coefficient of x squared in this second expansion. These were the two things that we were looking for. Now they're saying the coefficient of x cubed in that first expansion, which is this 720a cubed, that is 6 times the coefficient in that second expansion. What's the coefficient from the first expansion that we were looking at? 720a cubed, right? That's the first one. This is supposed to be 6 times this second coefficient. What does that become? 6 into 240a squared. And now you just need to solve this, find the value of the constant a, and see what that turns out to be. Now in this case, a cannot be 0. The proper way of solving this would be, you would say this is 720a cubed. That equals 6 into 240. That's giving me 1440 into a squared. Bring a squared to the left side. That gives you 720a cubed minus 1440a squared equals 0. You would take a squared common. That leaves you with 720a minus 1440 equal to 0. That means either a squared equals 0 or 720a minus 1440 equals 0, you get either a equal to 0 here, or you get a equal to 1440 divided by 720, and that's going to give you 2. You have two possible values of a that you're getting from this. However, 0 is not possible. Why is 0 not possible? Because if a was 0, what would happen to this term? This would become 0. So it will just be 3 raised to power 5 that's left. And similarly, if a was 0 here as well, we would just be left with 2 raised to power 6. And we would not have any coefficient of x cube and the coefficient of x square in those expansions. So the value of a therefore cannot be 0. So we say this is not possible. The only answer that we get is a equal to 2. And that's the result that we were looking for. The value of a turns out to be 2. And in the question as well, it's pretty clear. It says find the value of the constant a. If you could get multiple answers, the question statement would be different. They would say find the possible values of a, right? Since the question says find the value of the constant a, that means it has to be only one answer. You can't write multiple answers here. So 0 is not possible. You would have to ignore this. Now, some of you might be thinking, can't we just cancel a out here like this with one power, with power 2 cancelled and only a left there? You could do that in this case because a cannot be 0 in this case. However, you should not make a habit of doing something like this because in general, if you had this equation, this would also have one possible answer, that is a equal to 0. If you make a habit of cancellation, of doing cancellation like that, you can end up missing out on that one possible answer and you could lose marks because of that. In this question, however, since the value of a cannot be 0, it would have been okay even if you were to cancel a out, a square out in this case like this. You could say it's 720a cubed divided by a square equals 1440, and that would work. A square will get cancelled with power 2 in the numerator, and you would just be left with 720a equals 1440 with a being equal to 2 only because the value of the constant a cannot be 0 here. That's why you can do the cancellation. But the proper way of doing this would be like this, by bringing all the terms to one side, taking a common, and then writing down two possible answers. Okay. Any question on this? Any question on this? Should we move on? I would want, so since it's an online class, I can't see you guys. Otherwise, in physical classes, we can see the expressions of students and understand, okay, if they understand something or not. In online classes, it really helps the teacher if you can, respond at least in the chat box if you understand something or not. So just tell me if you understand something. If you have any questions, write them in the chat box. And do that regularly after every question, okay? Is that okay to everyone? Make sense? Okay, great. All right, let's move on to the next one. Question number 2. Find the exact solution of this equation. Now, whenever it says exact somewhere, what does that mean? That means your answer cannot be in decimals. You cannot use decimals anywhere, okay? Exact means you cannot use decimals. Now, you should understand the question statements like this properly as well. Just like in the last question, I told you when it says find the value, that's basically telling you there has to be only one answer. You can't have multiple answers. So keep making notes of this as well, that how you, what different things can you understand from the question statement. Now, in this case, for instance, they're saying find the exact solution. That means you can't have answers in decimals. What it also means is whenever the examiner asks you for an exact answer, it's extremely important to show every single step in your working, because the examiner wants to see if you know how to do that whole process and you have not just evaluated the answer from your calculator directly. Okay, so you need to make sure that you are showing every single step to the examiner very clearly. Okay, that's important. Now, how do you solve this equation? It looks pretty complicated, right? 1/6 times pi plus tan inverse of 4x equals minus cos inverse of 1/2 into under root of 3. Now we've got two different functions. We've got tan inverse here. We've got cos inverse here. Now, can we simplify this somehow? You have tan inverse of 4x. There's nothing you can do with that, right? You can't input tan inverse of 4x in your calculator. However, on the right side, you see you have cos inverse of under root 3 over 2. That's a constant inside that. This is something that you can actually evaluate on your calculator. Just put this on your calculator, the right side, and see what that gives you, making sure it's an exact value. Cos inverse of under root 3 over 2. What does that give you? Your calculator has to be in radian mode, remember? It has to be in radian mode. So make sure it's in radian mode. Remember the general rule for paper 1 and paper 3. Always use radians unless the question statement explicitly uses degrees. Okay, in general, you have to use radians always, unless the question statement uses degrees explicitly. So they would have the degree sign somewhere in the question. If they don't, always use radians. In equations like these, you cannot have degrees. And in this case, you can get a hint from this as well. It's pi over 6. Generally, only angles in radians are written in terms of pi. Now, what's cos inverse of under root 3 over 2? You must have a calculator with you that gives you exact values of such functions. So in this case, my calculator is giving me minus pi over 6. If you remember them by heart, that's perfect. But still, you should verify them from your calculator. This is minus pi over 6. Okay, so now we've got something relatively simpler as compared to before. Okay, so we have 1 over 6 pi on the left side, and on the right side we have minus pi over 6. Now, when this goes to the right side, what does that become? Minus pi over 6 minus pi over 6. Again, you could do this LCM yourself, or you could just put this on your calculator, and that's perfectly okay. Okay. So minus pi over 6 minus pi over 6. What does that become? That simplifies to pi over 3 minus pi over 3, right? Minus 2 pi over 6, which becomes minus pi over 3. So this can be simplified to minus pi over 3 like this. That's what we're getting. Now remember, we want an exact solution. Okay, what do we do next now? This is tan inverse. Tan inverse of 4x equals minus pi over 3. All right. Now, we can't evaluate this. We can't evaluate tan inverse 4x because we can't input x in the calculator like this. At least the calculator is not going to give us a result for that. So what do we do instead? This is tan inverse on the left side. If we take it to the right side, what is that going to become? It's going to become tan, right? It's going to become inverse of that. So we can take this tan inverse to the right side, just like if you have tan x equal to 1, for instance, you say x equals tan inverse of 1. Now you have tan inverse of something. If you want to take it to the other side, it becomes tan. So in this case, it would become 4x equals tan of minus pi over 3. And now again, just put this on your calculator and see what that gives you. Tan of minus pi over 3. What does the calculator give on this? Minus pi over 3. Tan of this, that's minus under root 3. And now you just take 4 to the other side. That gives you minus under root 3 divided by 4. This is the exact value of x that we're getting. Does that make sense? Any problem with this? Okay. So if you have any questions, make sure to raise your hand and I'll ask you to speak then. If not, we're just going to move on now. Let's look at the next one. Question number 3. So now we have the equation of a curve that is such that dy over dx equals this. The curve passes through the point P. That's what we're given. We need to find the equation of the normal to the curve at the point P. So we have some curve. What we are looking for is the equation of the normal to the curve at a point P. Now, we don't know what the curve looks like. Just to understand the situation better, I can just make a rough sketch like this. Let's say this is what the curve looks like. So there's some point P somewhere. This is the point P, let's say. And this point P has coordinates 2 and 8. What's the normal going to look like? Normal is the line that is perpendicular to the curve at this point. This is the normal. Okay. Now it's a straight line. How do you find equations of straight lines? You need two things for that. You need a point and the gradient, right? And you can use y minus y1 equals m into x minus x1 then to find the equation. So what do we do now? We have a point already. This is the line for which we are looking for the equation, for, right? It's a straight line. Do we have a point on this line? Yes, point P lies on this line. So we can use that point. We can say one point that we have on the line is 2 and 8. There's just one other thing that we're looking for that we need for writing down the equation, and that is the gradient of this line. Now, how do you find gradient of a normal? Normal is perpendicular to a curve, right? So whatever is the gradient of the curve at that point, the gradient of the normal is going to be negative reciprocal of that. What's the gradient of curve at this point? Let's just put that point here in this equation, in this derivative, and see what that gives you. You have to do it on the left side. This is the derivative. Let's put x equal to 2 here in this derivative to find the value of the derivative at this point, right? Let's see what that turns out to be. 1 over 2 into 2 plus 72 over 2 raised to the power 4. Now let's see what that gives us. 1 plus 72 divided by 16, and that's giving me 11 over 2. Now what does this represent? This represents the gradient of the curve. This is the gradient of the curve at the point P. This is the gradient of the curve at the point P. Now, what about the gradient of normal? It's just the negative reciprocal of that. So now what we have is, we have a point, this is 2, 8. We have the gradient of normal, which is going to be negative reciprocal of this number. So change the sign, take reciprocal, that gives you minus 2 over 11. That's the gradient of the normal. And now you can write down the equation. You can say, this is the standard form, y minus y1 equals m into x minus x1. Just input values in this, and you get y minus y1, which is 8, equals m, which is minus 2 over 11, into x minus 2. And that's the equation of the normal that we were looking for. Okay? Now, since the question does not require you to convert it to a specific form, it's perfectly acceptable to leave it like this. You don't necessarily have to convert it to y equals mx plus c form or any other particular form. It's okay to leave it like this as well, and that's acceptable. Okay? That's the equation of the line. If you wanted, you could also simplify this further, making y the subject, writing in y equals mx plus c form, and that's also fine, but that's not necessary for you to do. Okay, now it says find the equation of the curve. You have the derivative of the curve. How do you go from derivative of a curve to the equation of the curve? You have to integrate, right? So you have the derivative. Let's find the equation of the curve from that. dy over dx equals 1 over 2 times x plus 72 over x raised to the power 4. In order to use the power rule, what we can do is we can bring this x to the numerator. What does that become? That becomes x raised to the power minus 4. Now you have to integrate this. You need to integrate this to find the equation of the curve. Now, how do you integrate? Half x. 1 over 2 remains as it is. The constant that's multiplying, that does not change. What about x? What's the integration of x? Add 1 to the power, divide by that new power. Integration of x is x squared over 2. Plus 72 remains as it is. Add 1 to the power, minus 4 plus 1, that's minus 3. Divide by that new power, you divide by minus 3. And you see what that gives you now. X squared over 4 minus, because of this negative sign here, it's going to be 72 divided by 3, that's 24, minus 24 x raised to power minus 3. Or you could write it as 24 over x cubed. However, remember, whenever you integrate, you also need to have a plus c. All right, unless you're inputting limits somewhere, in that case, you can ignore c as well. However, apart from the case when you have to input limits, you always have a plus c. So once you've integrated, remember to put a plus c there. And now you need to find the value of the c somehow. How do you do that? You know that this point P lies on the curve. You just input this point P there, find the value of C, and that is going to give you the equation of the curve. Okay, let's input this point C there and see what that gives you. So point P, sorry, that's 2 and 8. Yeah, so on the left side, in place of y, put 8. On the right side, you have 2 raised to power 2 divided by 4 minus 24 over 2 cubed plus c. You can see what the value of c turns out to be here. Please make sure that you're checking my calculations as well, just so we make sure we're not doing any careless errors. 8 minus 1 plus 24 divided by 8, and that's giving me 10. The value of c turns out to be 10 here. Okay, so what's the equation of the curve then? Now you can write down the equation of the curve. You would say y equals x squared over 4 minus 24 over x cubed plus 10. That's the final equation that we have. Any questions on this? Any questions, anyone? No? Make sense? All right, let's move on. Question number 3. Now, let's move on to question number 4 now. It says the diagram shows the shape of a coin, the 3 arcs AB, BC, and CA. They are parts of circles with centers C, A, and B, respectively. Okay, now what that means is the first arc, it corresponds to this center C. So basically, this arc AB has this center C. And similarly, you can actually just represent that in different colors, so it makes clear. This is one arc, then you have another arc, which is AC. The center of this arc is this point B. And then you have the third arc, that is BC. The center of this arc is at the point A. These are 3 arcs that we have. ABC is an equilateral triangle with sides of length 2 centimeters. That means this triangle, A, B, and C, this is an equilateral triangle. What that means is all of these sides are equal. So this is also 2 centimeters, and this is also 2 centimeters. So the radius of all of those 3 arcs, that is the same. Okay. Now what we need to do is we need to find the perimeter of the coin. Now what's the actual coin? Triangle is something that we have drawn ourselves. The coin is basically this arc, and this arc. It's the sum. It's basically made by combining those 3 arcs. What's perimeter? Perimeter is basically length of the boundary of a shape. Now, these are the 3 arc lengths that we have in the boundary. All you have to do is find the length of one of these arcs and just multiply that by 3, and that's going to give you the perimeter. Now, what's the arc length formula? S equals r theta. Now, remember, for using this formula, your angle has to be in radians. Do not forget that. We have the radius already. Radius is 2. What about the angle? What's the angle going to be? It's an equilateral triangle. So if we focus on, for instance, this sector, the radius is 2. What about this angle? This angle is part of an equilateral triangle. An equilateral triangle has all angles equal, which are 60 degrees. In radians, that would be pi over 3. So all the angles are pi over 3. So this angle, for instance, this is also pi over 3. And similarly, the rest of the angles are also pi over 3. So what's the arc length then? Radius is 2 into pi over 3. And that gives you 2 pi over 3. That's one arc length. So what's the perimeter then? Perimeter is 3 times 2 pi over 3, because we've got 3 arcs like this, right? So what does that become? That becomes 2 pi. That's the perimeter of this whole figure. Now it says find the area of the face ABC of the coin. So we want to find the area of this complete figure. We want to find the total area of the shape. Giving the answer in terms of pi and under root 3. Now, again, how do you understand this requirement, pi and under root 3? Do not get scared by this, that where are we going to get pi from, where are we going to get under root 3 from? All this means is you need an exact answer. Just do not convert any value to decimals, and you would automatically get something that is in terms of pi 3. It will automatically happen. You will not have to do anything additional for that. Okay? It's automatically going to be in terms of pi and under root 3. So how do you find this area? It's not a standard shape that we can find the area for directly anywhere, right? So we'll have to divide it into some parts somehow. Now, how can we think about this? Now, one possibility could be that you divide this area like this. You say you have an equilateral triangle, and you have 3 segments. There's one segment here, there's another segment here, there's another segment here. That is one possibility. That's one possible way of dividing this diagram. I think that's the most obvious from this diagram. So you just find all of these areas individually, one by one, find the area of the triangle, find the area of one segment, multiply that by 3, and then just add all of those individual areas. So how do we go by doing this? Let's find the area of the triangle first of all. We will need that for finding the area of the segment anyway. So let's find the area of triangle first of all. Area of the triangle ABC. It's an equilateral triangle. We know the angles, we know all sides. We can use half into AB sine C, right? Half AB sine theta. Just use that. So you can say half into the sides. One side is 2, another side is also 2. So we can say half into 2 into 2. Into sine of the angle between these two sides, that's pi over 3. And see what that turns out to be. Now, again, it's very important. You see, they want you to give an exact answer. Do not write down the final result from this directly. Sometimes the examiner expects you, and according to the marking scheme, to write down this result separately first of all. What is sine pi over 3? First of all, write this thing separately. Even if you're evaluating this on your calculator, that's perfectly okay. Do not write down the answer directly. First, write down what sine pi over 3 is. What is sine pi over 3? Again, put that on your calculator. In this case, 2 and 2 get cancelled. We have 2 outside. What's the value of sine pi over 3? Sine pi over 3, that's under root 3 over 2. But you can do this on your calculator. And now you can do the cancellation again. 2 and 2 get cancelled. And the result turns out to be under root 3. That's the area of the triangle ABC. Okay, so you should show this step. In some marking schemes, they have this requirement that you need to write down this value separately first of all before you write down your final answer. So that's important. Okay. All right. So we have the area of the triangle ABC. Now next, we need the areas of these segments. We can find area of any one segment first. Let's start with this one. And then we can just multiply that by 3, right? Or in fact, since we have already written the angle here, let's find this segment. How would you find the area of the segment? Find the area of sector, subtract from that area of the triangle. That will give you the area of the segment. Or those of you who know about it, you have a formula for segment directly as well, which comes from that same idea, sector minus the triangle. That will be half into, let me actually write down the formula first. It's half r squared into theta minus sine theta, right? And that's basically coming from that same two formulas. Area of a sector. What's the area of a sector? Half r squared theta. Subtract from that the area of the triangle. For the area of the triangle, now if you think of it in terms of a sector, in terms of this sector, we can call these lengths the radii, right? Both of them are 2. So it'll be half into r into sine of theta. So it becomes half r squared into theta minus sine theta, right? So you can remember this for later. For area of segment, you can use this formula directly, right? It comes from sector minus triangle. In this case, however, since we have already calculated the area of the triangle, we can just use that directly with rather than doing all of that process again. Since we know the area of the triangle already, we can just say it's under root 3, okay? And this is the area of the sector. From that, we are subtracting the area of the triangle. What's the area of the sector? Half r squared, the radius is 2. So we say half into 2 squared into theta. What's the value of theta? It's pi over 3 minus under root 3. Now you can simplify this and see what that gives you. 2 and 2, this power gets cancelled, and you're left with 2 pi over 3 minus under root of 3. Okay, that's what we're getting here. That's the area of one segment. Make sense? Now, what about areas of all of the segments combined? You just multiply this by 3. And then for the complete figure, you would add it to under root 3. Okay. Now, in this case, you see, I've now figured out that there's no space after this. So it would have been a better idea to look at how much space you have and then basically do your working in a way that you don't have to use more space after this. So in this case, for instance, you could do it like this. You could say it's area of triangle ABC. You can do that here. And then you have area of a segment. And that's here. So these are two things that we have. Now, what about the total area? For the total area, we just add the triangle to those 3 segments. Under root 3 plus 3 times 2 pi over 3 minus under root 3. And now you can evaluate this from a calculator directly as well if you want, because now you don't have to evaluate any trigonometric functions as such. This is just algebraic simplification. So it's perfectly okay to do this on your calculator directly. Remember to leave your answer in exact form. So you have under root 3 plus 3 into 2 pi over 3 minus under root 3. Now, okay, so if I put all of this in my calculator directly, that's not giving me an exact result. So let's break it down then. Under root 3 minus 3 under root 3. And that's going to give you minus 2 under root 3. So this is minus 2 under root 3. By just adding these two terms, under root 3 plus 3 into this, that's minus 2 under root 3. And then you have 3 times this, that becomes 2 pi. So this is the total area in terms of pi and under root 3. Okay, that's what we're getting. Any problem with this? We can't simplify this any further. It's 2 pi minus 2 under root 3. How would you simplify it further? What can you do after this? Yes, Batul?
Sir, can you please explain why we are adding under root 3 in the total area again?
This is the area of one segment. That is this part. We multiply that by 3 to get the areas of all of these segments. This segment, this segment. That's this part on the right. What about the triangle in the middle? The triangle in the middle is under root 3. So we have to add
Okay.
all of them up, right?
Thank you.
Okay. Yes, Marina. So, so the question is, can we leave our answer up to this step? No, you have to simplify it further. You can't leave it in this step because it is possible to simplify this and write it like this. So you have to do it until this last step. You can't leave it here. Okay. Now, again, it's sometimes they might give you marks for this. Sometimes they would not. So you should not risk it because it's not very obvious always when they're going to deduct marks for this, when they're not going to deduct marks for it. It's kind of random in the sense that if the question carries more marks, then they would have 1 mark for the simplification at the end. If the number of marks is not that much, then the distribution of marks might allow this as the final result as well. So it depends from one paper to another. So the safer thing is to always simplify to this last step. All right, so you should be doing that. All right, let's look at the next one now. Question number 5. Abdullah, this is not outside the page and on the math. So basically, on the right side, if they have lines, then you should not do anything outside those lines. However, in this case, up to this part, it's perfectly okay. So sometimes they have vertical lines on the sides of the paper, and they might ask you not to write on the sides. Generally, on the math paper, it's not like that. It's so I think what you're asking about is, can we go beyond these dotted lines? Yes, you can write on the right side, write on the left side. That's perfectly okay. There's no problem with that. So this is okay. This is okay. No need to worry about that. Okay. All right. Now, first, second, and third terms of a GP are sine theta, cos theta, and 2 minus sine theta, respectively, where theta radians is an acute angle. Find the value of theta. Okay. Now it's a GP. It's a geometric progression. So let's write that down. It's a geometric progression. And we're given the first 3 terms. One term is sine theta. And the first is sine theta. And then the next is cos theta. And then the next is 2 minus sine theta. These are 3 terms that we have for this GP. Theta is the angle in radians. We need to find the value of theta. Now, what do we know about a GP? A GP has the ratio between its terms constant. The ratio between terms in a GP is constant. Now, one idea could be to use the term formula here, as in use T2 equals AR, and then use T3 equals AR squared. Put AR equal to cos theta, put AR squared equal to this. However, in questions like these, where you have 3 consecutive terms given in a GP, for instance, it's much quicker and easier to use something like this. Since these are 3 consecutive terms, you can say the ratio between the terms of this GP can be calculated like this. You can say the ratio is T2 over T1. Next term divided by previous term. If you look at these 2 terms, the ratio would be T2 over T1. The ratio would also be calculated as T3 over T2. If you look at these 2 terms, T3 over T2 should also give you the ratio. That gives you an equation like this. That's this equation. So basically, you have, now just to make sure we have space on the right side later on if we need that, just take it to the left a bit. Okay. This part basically gives us an equation. T2 over T1. What's T2? T2 is cos of theta. What's T1? T1 is sine theta. That should equal T3, which is 2 minus sine theta, divided by T2, which is cos theta. And that gives you an equation directly. So you don't have to worry about those term formulas in cases like these, where you have consecutive terms given. You can make a direct equation like this. Okay. And now we just have to solve this equation. It's a simple trigonometric equation that we need to solve. You can cross multiply. If you cross multiply, that gives you cos square theta equal to sine theta gets multiplied here. And that will give you 2 sine theta minus sine square theta. We need to solve this trigonometric equation. Now, the problem is we have two different functions. We have sine here and we have cos here. We need to convert it to one single function. What we can do is we can write cos square as 1 minus sine square. So it becomes 1 minus sine square theta equal to 2 sine theta minus sine square theta. Now take everything to one side, and that's going to give you, in fact, sine square gets cancelled. When this goes to the other side, sine square theta minus sine square theta, it will get cancelled. And you're just going to be left with 1 equal to 2 sine theta, and sine of theta equals 1/2. Now, they have given you that theta is an acute angle. That means it's in the first quadrant. So you only have to consider angle in the first quadrant. That means it has to be the smallest positive value. So you don't need to worry about finding the basic angle and then using quadrants, etc. Because in this case, it's pretty clear. It's the first quadrant. You can write down the answer directly. Sine inverse of 1/2. What's that? I think it's pi over 6, right? You can do this on your calculator. That's your final result. Theta equals pi over 6. Okay, that's what we were looking for here. Next, look at the second part. Again, if you have any questions, make sure to raise your hand. Otherwise, I'm going to keep moving on. I hope that makes sense. Let's move on to the next one. Part B. Now it says, using this value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over under root c minus 1, where b and c are integers to be found. So again, they want an exact answer. They don't want you to convert anything to decimals. Okay, so what do we do here now? Sum of the first 10 terms. It's a GP, right? It's a GP. Mariam, I'm not sure if I understand your question. What do you mean by derive? You mean derive T2 over T1? We're not really deriving anything here. We're just saying cos theta over sine theta. That equals 2 minus sine theta over cos theta. Since the ratio is constant, any two consecutive terms that we take, their ratio should be the same. So we're taking the first two terms and these two terms. It's not necessary for you to write this particular step. If you wanted, you could write this directly, this equation directly. But the previous step is basically just for your notes that this is where it's coming from. I hope that makes it clear. If not, you can maybe clarify your question a bit more. Yeah, okay, good. Using the value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over under root c minus 1, where b and c are integers to be found. Okay, now we need the sum of this GP. What's the sum formula for GP? It's given in the formula sheet. It's written like this: a into 1 minus r raised to power n divided by 1 minus r. Just input values in the formula. You want S10. Okay, so the value of n, therefore, is of course 10. What about a and r? A is the first term. What's the first term? The first term is sine of theta. Let's write that down here. Sine theta, we know the value of sine now. So we can say it's sine of pi over 6. We know the value of theta. Theta is pi over 6. So it's sine of pi over 6. Sine of pi over 6 gives us 1/2. So the first term is 1/2. Now the second thing that we want from this formula is, for using this formula, is the ratio. How do you find the ratio? You could do T2 over T1, or you could do T3 over T2. So basically, either this or this. Use any one of these two. Let me use cos theta over sine theta. That's going to give me cos of pi over 6 over sine of pi over 6. Now, what's cos of pi over 6? Cos of pi over 6 is under root 3 over 2. Sine of pi over 6 is 1/2. 2 and 2 get cancelled, and we're left with r equal to under root 3. So we have the value of a, we have the value of we have the value of r. Just input them in the formula that we've got and see what that gives you. We want S10. Sum of the first 10 terms. A is 1/2 multiplied by 1 minus R. R is under root 3 raised to power n, which is 10 brackets closed. In the denominator, we've got 1 minus under root 3. This is what we've got. Okay. Now let's simplify this. Remember, we can't use decimal, so don't try to evaluate this on your calculator. Or let me actually see if we can actually get something here. Let's simplify this and see what that gives us. So we have 1/2 minus 1/2 into under root 3 whole raised to power 10. What do you get from that? Yeah, so that's actually going to give you an integer. Under root 3, what's under root 3? Under root 3 is the same thing as 3 raised to power 1/2. Let me actually keep 1/2 outside. And first simplify this to make things simpler. 1 minus under root 3. Under root 3 is basically 3 raised to power 1/2. Then you have whole raised to power 10. What does that become? 10 into 1/2. That's 5. So you have 1 minus 3 raised to power 5 here. Make sense? This part becomes 3 raised to power 5. In the denominator, you've got 1 minus under root 3. Now you can simplify the numerator. 3 raised to power 5. What's that? Let's just evaluate this on a calculator. 3 raised to power 5. That's 243. 1 minus that. That's minus 242 divided by 2. The numerator turns out to be minus 121. And the denominator is 1 minus under root 3. That's the sum that we are looking for. However, now look at the form that they want. In the numerator, they want an integer. We have an integer, although it's negative, but they did not specify that the integer had to be positive. So we have an integer. But look at the denominator. Denominator is not the form that they want. They want under root of something minus 1. We have 1 minus under root of something. So what we want to do is we want to flip these signs somehow. For that, what we can do is we can just multiply this negative sign that we have in the numerator in the denominator instead, right? Because if you have, for example, minus 5/7 or 5/-7, they mean the same thing. Or minus 5/7 like this, all of these are the same thing. If you have a negative sign with the numerator, you can put that with the denominator as well, as long as it's applying to the whole thing. So that's one way of thinking about this, that you just multiply this negative sign in the denominator. Another way to think about the same thing is you multiply and divide this fraction by minus 1. So this is a trick that we sometimes use as well to basically change the order in which a term appears. They multiply and divide by minus 1. So multiply the numerator by minus 1, multiply the denominator by minus 1. And that gives you the same thing. In the numerator, that you get 121, it becomes positive. In the denominator, when minus 1 gets multiplied here, it becomes under root 3 minus 1. And that's the sum that we were looking for. Okay. Now it says B and C are integers to be found. Although it's not necessary, they have not asked you to asked us to state the value, but it's a good idea to state the value of B and C here as well. The form was B over under root C minus 1. Just compare with that and see what the values of B and C are supposed to be. According to this form, B is equal to 121 and C is equal to 3. But in this question, it's not necessary. Sometimes they ask you to state the values of those constants. In that case, you will state it like this. Make sense to everyone? All right. Okay, now that's a good question. So the question is, why do they sometimes give you a whole page for something small like this, and then they give very little space for something big? My guess to that is they don't solve the paper themselves before they put it, and that's pretty evident from some of the recent papers because some of the M1 papers, especially I'll direct you to one November 2021 paper. I think it's paper 4 variant 2 or variant 1, one of those two. It's a paper that is impossible to solve in time. It's simply not possible. When you do it the very first time, it's impossible to solve in 1 hour 15 minutes. And it's clear from the threshold. The threshold for that paper was 28 for an A, 28 out of 50, because hardly anyone, I think no one, would have been able to complete the paper in time and do it correctly as well. So sometimes it happens that they realize later that, okay, this question is maybe a bit too difficult or a bit too long. And that probably happens here as well. They think it would not take a lot of space, and then it ends up taking a lot of space. So yeah, you just have to make sure that you write slightly smaller, so that in case you need more space, you have that extra space available there. Which paper? It's November 2021. Some variant of paper 4. I'm talking about M1. I don't remember the exact variant. I think it's a 1 or 2 variant, 4.1 or 4.2, November 2021. Okay. All right. So I think the rest of the questions we can have a look at later on because they're not relevant. But yeah, we can discuss it maybe at another point, another night. Maybe after the next class, if you're also part of the mechanics session, because right now we're running out of time. Let's move on to the next one. Equation of a curve is y equals this, y equals x squared minus 8x plus 5. Find the coordinates of the minimum point of the curve. How do you do this? It's pretty straightforward. You have multiple methods of doing this. Turning point of a quadratic function. You could complete the square for this. You could use minus b over 2a. You could use differentiation. For quadratic functions, you have multiple options. You can use any of those methods. Let's use minus b over 2a. That gives you the x coordinate of the turning point of a quadratic function. Minus into minus 8. This is the value of b, right? Divided by 2 times a, the coefficient of x squared, that's 1. What does that give you? That gives you 8 over 2, that's 4. That's the x coordinate of the turning point. Put this value back in the function, and that gives you 4 squared minus 8 into 4 plus 5. Okay, so what do we get from this? 16 minus 8 into 4 plus 5. That's minus 11. So the coordinates of the minimum point, therefore, what are they? 4 and minus 11. You could use completing square as well, although I would suggest the other two methods are easier. Minus b over 2a. You could use differentiation if you wanted. That would have given you the same result. Okay, that's the turning point, the minimum point. Okay, now we have transformation. It says the curve is stretched by a factor of 2 parallel to the y-axis and then translated by 4, 1. Find the coordinates of the minimum point of the transformed curve. Okay, so how do we think about this now? This is the turning point. After transformation, after applying those transformation, it's going to move to some other place. Where exactly is this going to move after these transformations that they've given? Now, let's think of them one by one. What's the turning point originally? It's 4 and minus 11. Okay. Now, what happens with these transformations? Factor of 2 parallel to y-axis. What does that mean? It's a vertical stretch. So the first thing that happens is a vertical stretch with scale factor 2. Vertical stretch. What does that mean? Only the y coordinate is going to change. The y coordinate is going to get multiplied by 2. So after this transformation, what happens is this point 4 minus 11, where does that go? It goes to 4 minus 22. The y coordinate gets multiplied by 2. Right? That's what stretch does. Whatever is the scale factor, your coordinate gets multiplied by that number. So that's what we get. Okay. So after the first transformation, this is what happens. Now, what's next after that? There's a translation. There's a horizontal translation. There's a vertical translation. What's the translation? Let me write that down here as well. The translation is 4, 1. That means in the x coordinate, you're going to add 4. And in the y coordinate, you're going to add 1. So what do you get from that? 4 plus 4, because it moves 4 units to the right. What does that give you? 8. Minus 22 plus 1, because it's going to move 1 unit up. Minus 22 plus 1. What does that give you? That gives you minus 21. This is going to be the final result that you get. So how does every point on the curve move? Every point, its y coordinate gets multiplied by 2. That's the first thing that happens. And then you're adding 4 to the x coordinate and adding 1 to the y coordinate. And that gives you this final result, which is 8 and minus 21. Is that okay? No questions? Okay, let's move on to the next one. Part C. Make sure that you're asking questions if you have any problems, because that's the whole point of doing this, that if you don't understand something, you ask about that. Of course, assuming that you have done the concepts already. If something makes you realize that maybe you're struggling in some particular concept, make sure to go back and revise that. That's also the purpose of this, right? To identify which topics you need more practice on, so that you can improve on them. Okay. All right. Find the equation of the transformed curve. Give the answer in the form y equals ax squared plus bx plus c, where a, b, and c are integers to be found. Okay, so the curve is y equals x squared minus 8x plus 5. Now, it's a quadratic function. When you are required to figure out what transformations are happening in a quadratic function, you always need to complete the square first. Otherwise, you will not be able to figure out what transformations are happening. If you are asked for what transformations are happening, but if the transformations are already given, like in this case, the transformations are already given, they've told us the transformation that we're doing. In that case, it's not necessary to complete the square. It might make it slightly easier after that, but completing the square itself is going to require some working. You could do that here if you wanted, but it's possible to do it directly as well. It's not necessary to complete the square in this case, because the transformations are already given. We just have to apply those transformations. What are the transformations? It says it's a vertical stretch with scale factor 2. What does that mean? The whole function is going to get multiplied by 2, right? Because the whole function is y. Y equals this whole thing. So the y coordinate gets multiplied by 2. So that means the whole thing gets multiplied by 2. So that's the first transformation that happens. So after vertical stretch with scale factor 2, what happens is the function becomes 2 into x squared minus 8x plus 5. That's the first thing that happens. Okay. Then there's a translation. Translation is 4, 1. Translation is 4, 1. Now, what happens when that translation is done now? 4 is horizontal transformation. 1 is vertical transformation. Now, vertical transformations are easier to deal with. Let me write down the vertical result first of all. It's going to be 1 added to the whole function like this, right? For vertical transformation, this is all that happens. 1 gets added to the whole thing. All right. What about this 4? That's horizontal transformation, 4 units to the right. In horizontal transformations, things work a bit counterintuitive, right? You should know that. If it's plus in the function, the graph moves left. If it's minus in the function, the graph moves right. If you multiply x by something, the scale factor is reciprocal of that. So it works the other way around in horizontal transformation. So basically here you have 4. If you had to apply that transformation, the horizontal transformation to this function now, wherever you got x, you're going to replace x with what? X minus 4. So it becomes x minus 4 whole squared minus 8 into x minus 4 plus 5. So every x gets replaced with x minus 4. And then you can write down the final result. They are basically asking you to write down the answer in this form. Now you can just simplify everything and see what that gives you. So you have 2 into x squared minus 8x plus 16 minus 8x plus 32 plus 5 plus 1. Multiply 2 with this whole thing, and that's going to give you 2x squared minus 16x plus 32 minus 16. I think we can, or it's okay. Just multiply everything. 2x squared minus 16x plus 32 minus 16x plus 64 plus 10 plus 1. Or you could simplify the part inside bracket first before multiplying by 2. Any way you prefer. Now you can write down the final result. That's 2x squared minus 32x. Then you have 32 plus 64 plus 10 plus 1. That's 107. Y equals this whole thing. This is what we are getting. Is that okay? Another possibility could be to complete the square first, and that will probably make it easier to understand the transformations. So what would be the completed square form of this? You would say x squared minus 8x plus 4 squared minus 4 squared plus 5. And the completed square form would look something like this. X minus 4 whole squared minus 16 plus 5. That's minus 11. Right? And then you could apply those transformations. You have vertical transformation by a factor of 2. Right? That's the first thing that happens. Let's multiply this whole thing by 2. 2 into x minus 4 whole squared minus 11. That's the first thing that happens after a stretch. And then translation. So it becomes, so remember the vector for translation? The vector was 4, 1. 1 unit vertically upwards. So you have plus 1 outside. Okay. And then inside, in place of x, you're just going to do x minus 4. So what does that become? X minus 4 in place of x. And you have minus 4 here already. And minus 11. I hope that makes sense. So what I've done is, I've first multiplied by 2 here. That's the vertical stretch. And then this is the vertical translation. And this is the horizontal translation. And now you can simplify this and see what that gives you. 2 into x minus 8 whole squared minus 11 plus 1. And now you could expand this and you would get the same result as before. That's x squared minus 16x plus 64 minus 11 plus 1. And simplifying this would give you 2x squared minus 32x. 53 into 2 plus 1, and that's 107. You'll get the same result from this as well. This could be another way of doing this. Okay, so you could complete the square as well here, or you could do it directly. Both of them work. Why? Because the transformations are already given. If the transformations were not given, you would not be able to figure out the transformation. So if you had to find the transformations, yourself, then completing the square would be necessary. Otherwise, you would not be able to understand what transformations are happening. So you have to complete the square in that case. But in this case, the transformations were given already. You just had to apply them. In this case, you can do it either way. You can do it directly, or after completing the square, both work. Okay. We are subtracting 4 here because remember in horizontal transformations, it works the other way around. If you go right, you have to subtract. If you go left, you have to add to the function. In horizontal transformation, it works the other way around. Okay. Is this all right to everyone? Any problem with this? Okay, great. Let's look at the next one. Now it says verify this identity. Now that's pretty straightforward. You're going to simplify the left-hand side and see what that gives you. 2x into, now you have to show your working, right? So let's simplify the left-hand side. 2x into 4 squared, that's 8x cubed plus 4x squared minus 2x minus 4x squared minus 2x plus 1. And that gives you 8x cubed minus 4x plus 1. That's all that you have to do. The left-hand side equals the right-hand side, and it's proved now. Now, the second part says prove this identity. Now, notice they've asked you to verify this identity in the first part, and then they have introduced something completely different, which is some trigonometric identity that you need to prove. So keep in mind that you might need to use that. Yeah, so in part C, they've asked you to use those results from parts A and part B, right? So there's a purpose of making you do this. Otherwise, it doesn't make sense to ask you to do something in one part and then something totally different in the next part. So they want you to use these two together in the next part after this. So keep this in mind. And the second part, you just have to prove this identity. What do you do for this? Start from any one of the two sides and prove that equal to the other side. Let's start from the left-hand side. Okay, so how do we start with this? Remember what you want at the end. What you want at the end is this form. So let me write that down here. Tan square theta plus 1 divided by tan square theta minus 1. That's the left-hand side. You want to prove this equal to this right-hand side. Now, how do you do that? You have tan, you want to convert it to cos. Remember, there's only one identity that you know in paper 1 that involves tan, and that's tan equals sine over cos. What's tan square equal to? That's sine square over cos square. So what does it become? You can use that directly here and write it like this instead. You would say this is sine square theta over cos square theta plus 1 divided by sine square theta over cos square theta minus 1. Okay. Now you can take LCM in the numerator and also in the denominator. And in the numerator, when you take LCM, that gives you sine square theta plus cos square theta in the divided by cos square theta whole divided by sine square theta minus cos square theta whole divided by cos square theta. Now cos square and cos square, they get cancelled. What are we left with? We're left with sine square theta plus cos square theta divided by sine square theta minus cos square theta. What is sine square plus cos square? Sine square plus cos square is 1. So the numerator becomes 1, and the denominator, you have sine square theta minus cos square theta. Remember what you want at the end? You want something that's only in terms of cos. Can you convert the sine to cos as well? You can write it as 1 minus cos square. So you have 1 minus cos square theta minus cos square theta. And that becomes 1 over 1 minus 2 cos square theta. And that is what we were looking for. So keep the end in mind. What do you want at the end? You wanted something that's only in terms of cos. So you wrote tan as sine over cos and then simplified everything to get something like this. Does that make sense? Is that okay? All right. All good? Okay, let's look at the next part now. Now it says using the results of part A and part B, solve this equation somehow. Now, what have we done in the first two parts? In the previous part, you have this tan square theta plus 1 over tan square theta minus 1. You've proved this identical to this thing, 1 over 1 minus 2 cos square theta. So you can replace it with that. You can say it's 1 over 1 minus 2 cos square theta. That equals 4 cos theta. You had this equation that you wanted to solve. It had two different functions. You want to convert it to one single function to be able to solve it. We already converted this form to something that's only in terms of cos here. So that's what we can do. All right. We can just use that form instead of tan square theta plus 1 over tan square theta minus 1. Now, how do we solve this equation? Let's take this to the right side. It becomes 4 cos theta into 1 minus 2 cos square theta. That equals 1. Okay. Now, they want us to use the part A somehow as well. Okay, it doesn't look as relevant here for now, because these are two very different forms as of now. Okay, let's simplify this and see what that gives us, in case that gives us something similar to that. 4 cos theta minus 2 into 4, that is 8 cos cube theta equal to 1. If you were to bring everything to one side, that gives you 8 cos cube theta minus 4 cos theta plus 1 equal to 0. This is the equation that you want to solve now. Now, how do you solve this equation? It's a cubic equation, and you do not know how to solve cubic equations, right? You will learn it in paper 3 later on, how to solve some cubic equations, but for now, you don't know how to do this. Now, this is where the first part comes in. Yeah, so in the first part, you had this 8x cubed minus 4x plus 1. On one side, you can see we've got exactly the same thing here. Instead of x, you have cos theta. It's exactly that form. We proved in the first part that this thing on the right side, 8x cubed minus 4x plus 1, that can be written in factorized form like this. This is what we proved in the first part. So we can use that result. We can use this result. We can say, okay, this is what we proved in the first part. Instead of cos, we've got x. So let's convert it to this form that is given on the left side instead. And we could write this equation as 2 cos theta minus 1 into 4 cos square theta plus 2x minus 1 equal to 0. Or we could also do it like this to make it simpler. In fact, we could use a substitution. That will make things simpler. We could use let x equals cos theta. You could use a substitution like this. What does that equation become? If you use this substitution, this substitution, you get 8x cubed minus 4x plus 1 equal to 0. That's what this equation becomes. And they've already told us what the factorized form of that equation is. So you can write it in this form now. You can say this is the same as 2x minus 1 into 4x squared plus 2x minus 1 equal to 0. You can find the values of x from this. You can say either 2x minus 1 equals 0 or 4x squared plus 2x minus 1 equals 0. You get x equals 1 over 2, or you get this quadratic equation. Can you solve this equation? Can we factorize this? Minus 4. Okay, it doesn't look like we can factorize this. We can use the quadratic formula. X equals minus 2 plus minus square root of b squared. That's 2 squared minus 4 into minus 1 whole divided by 2 into 4. Writing down this step is necessary. Okay, writing down this one step is necessary, especially in paper 1. You are certain to lose marks here if you don't write the step and write down the answers directly. So you will input values in the quadratic formula, and then if you want, you can write down the answer after this and see what that turns out to be. So let me just do this on my calculator now after this point. Let's see what that gives me. Okay, so we don't want exact answers. We can't even get them here. So one possible answer is 0.3090 from this. Remember, this is working. This is not your final result yet. So you want more accuracy at this point. Don't round off numbers to 3 significant figures already. Use more accuracy here. And the second answer is minus 0.8090. Okay. And now we were not looking for values of x. We were looking for values of theta. So now we put that substitution back. We say either cos theta equals 1/2 or cos theta equals 0.3090 or cos theta equals minus 0.8090. Now the interval that we're given is from 0 to 180. Now keep that in mind. Interval is from 0 to 180. Find basic angle for each one of them. Remember, cos is positive in the first quadrant, negative in the second quadrant. These are the only two quadrants that you're looking at. So it's not actually necessary to write down the basic angles first and then the answers. In this case, you can see the only positive answers that are possible that are in the first quadrant. So cos theta equals 1/2. Just write down an answer in the first quadrant for that and see what that turns out to be. Cos inverse of 1/2. Now angle is in degrees. So now you see in the question statement, they've used degrees explicitly. So now you know that you have to use degrees. So your calculator has to be in degrees mode. 1/2, I think, is in 60 degrees. Let me just change my calculator mode as well. You need to remember to do that. Cos inverse of 0.5, that's 60 degrees. That's one possible answer that I'm getting. And then you do cos inverse of 0.309. And that's giving us 72.0 degrees. That's another possible answer that we're getting. And now the last one is negative. Now that means we want an answer in the second quadrant. In this case, you can just try inputting this directly, or the proper way of doing this would be finding the basic angle first. Let's actually do it that way. Let's find the basic angle. Cos alpha equals 0.8090. That's how you would do it generally. You'll find the basic angle. What's the basic angle that you get from this? The basic angle turns out to be 36.0 degrees. And then you see the basic angle is in the second quadrant here. That is 36.0 degrees. So what's the value of theta that you get? 180 minus 36. And that is 144.0 degrees. These are the three possible answers that we get. We get 60, 72, and 144.0 degrees. These are three possible answers that we have here. Any problem with this? Any questions, anyone? No? No problems? Okay. Okay, I think we need to be quicker from next time because this is taking a lot of time. So while explaining it, and answering questions alongside as well, it takes time. So we need to be a bit quicker about it. Maybe start a bit earlier as well. Okay, so f of x equals x plus a whole squared minus a for x less than or equal to minus a. G of x is 2x minus 1 for x being any real number where a is a positive constant. Find an expression for f inverse of x. Now it has to be in terms of a, right? Because this is f of x. When you find f inverse, you'll have this a here as it is. It will be in terms of that value of a. So let's do this. How do you start? You start by assuming f of x equal to y. Let's see what that gives us. Y equals x plus a whole squared minus a. Okay. Now, what do we get from this? We need to make x the subject now, right? So it becomes y plus a equal to x plus a whole squared. And now you take square root on both sides. But remember, whenever we take square root, we have to put plus minus, right? So it becomes plus minus square root of y plus a. And that becomes x plus a on the other side. Now take a to the other side. So it becomes x equals a plus minus square root of y plus a. So we have made x the subject here, right? That's the first thing that we had to do. We had to make x the subject. We're done with that. Now we need to decide whether to use plus here or minus here. We can only choose one of them, right? We can either choose plus or minus. Now, which one do we choose here? We need to decide that using this domain that we're given. What's the domain that we're given? I'm sorry, this is minus a here. When a goes to the other side, it has to be minus a. So let's check my working again. X plus a whole squared minus a. This had the domain given here. It becomes y plus a. And yeah, so that's what you have minus a here. Now, what's the domain that's given? The domain is x less than or equal to minus a. That's the domain that is given in the function. Now, using that domain, you need to decide whether to use plus here or minus here. The domain says x has to be less than or equal to a, less than or equal to minus a. How are you going to get values that are less than or equal to minus a? Are we going to get them using a plus sign or a minus sign? If we want something less than minus a, we'll have to subtract something from minus a to get a smaller value. So we need to have a negative sign here. So what does that become? That becomes x equals minus a minus square root of y plus a. So the sign has to be negative. Why? Because we want x to be less than or equal to minus a. If we are adding something to minus a, that will give you a value that's greater than minus a. That's not what we want. We want something less than that. So for that, we have to use minus sign. That's something that you always have to do in quadratic functions. When finding inverse, you always have to put plus minus when you take square root, but then you have to decide which one of plus or minus you are going to input there. So in this case, you have a minus here. And then you write down the inverse. You say the inverse function therefore is f inverse of x equals minus a minus square root of x plus a. That is f inverse of x. Is that okay? Any problem with this? Okay, good. Now, I'll complete this question and then I need to ask something. So we'll try to manage time better from next time. Can we continue with this at some point tonight? Will that work? So for example, what if we continue with this at 9:30 p.m.? How many of you would be okay with that? If we continue with this, after completing this question number 8, please raise your hand if you're okay with that. If we continue at 9:30 p.m. 9:30 p.m. Pakistan time, is it okay? If we complete this paper, I don't want to leave it for another day because we have a lot to cover in the next 15 days. And it's taking a bit long for now. So for next class, I'll try to start earlier and we'll try to manage it in time, hopefully. Okay, those of you who haven't raised their hands, do you have a class? So let me actually put it this way then. Anyone who has a clash with another class at 9:30, raise your hand if you have a clash with another class. Raise your hand if you have a clash with another class at 9:30 p.m. Okay, so nobody has a clash. What I'm going to do is I'm going to do it at that point. And tonight, I'll also post the recording. So in case for some reason you end up missing the class, so it will be around, I think, 30 to 40, 30 minutes, 30, 35 minutes or something. If you end up missing that for some reason, I'll post the recording tonight as well. And from next class onward, I'll try to make it slightly more efficient, slightly more quicker. And hopefully we won't have to do it after our regular time. But for today, we're running out of time. So we will have to continue with this at 9:30 p.m. Okay, after completing this question. Now, let me just post this on the M1 group as well, because there's time for namaz as well. So I'm just going to. We might have to do something with the timings a bit, 10-15 minutes here or there. Okay, just try to post in the other group that will be starting a bit late. But we need to do something about this, about the timing thing. Okay, so that was part A, okay? Yes, we'll have a break after this. Yeah, so for Maghrib, we'll have a break, yes. So before the M1 class, yes. So we'll start at 7:10, 7:20, inshallah. I'm just going to complete this question, and then then we end this class, okay? State the domain of the function f inverse. Okay, f inverse, domain of f inverse. What's the relationship between the domain of a function and the domain range of a function and the domain range of the inverse function? Domain of the original function is the range of the inverse function, and range of the original function is the domain of the inverse function. So if you want the domain of the inverse function, that's going to be the same as the range of the original function. What's the range of the original function? Let's think about that. It's a quadratic function. For quadratic functions, you always have to think using the graph of the function. What's the graph of this function going to look like? It's a U-shaped graph. The coefficient of x squared is positive, so the graph is going to be U-shaped. It's going to look like this. And it's going to be U-shaped like this. What's the turning point? Compare it with the standard form. Remember the standard form, x minus h whole square plus k. So the number that you have inside, you flip the sign for that. It becomes minus a. The x coordinate of the turning point is minus a. It's completed square form, right? And the number that you have outside, that sign remains the same. The y coordinate is minus a as well. This is the turning point. Now, which part of this function is valid? It's x less than or equal to minus a. That means to the left side of this function. This is the valid part of the function. This is the valid part of the function. Now, what's the range of the function then? Range is y value. So vertically, what's the lowest point on the graph? Lowest point on the graph is minus a. You have to be above this point. So the range of the original function is y greater than or equal to minus a. This is the range of the original function. I hope that makes sense, right? That's the standard process for finding range of quadratic functions. Look at the graph, look at what part is valid, and look at the graph. What's the lowest point? The lowest point is minus a vertically. Highest point, there's no highest point, it's going up to infinity. So the range is y greater than or equal to minus a. So now you would say, since the range of f, what's that? Range of f is y greater than or equal to minus a. What about the domain of f inverse? Domain of f inverse is going to be x greater than or equal to minus a. Remember, for domain, you always have to use x, right? So it's x greater than or equal to minus a. Is that okay? Now it says state the range of the function f inverse. What's the range of f inverse? The domain of the original function. What was the domain of f? Domain of f. What was the domain of f? It was x less than or equal to a. Minus a, sorry. What about the range of f inverse? It's also going to have less than or equal to minus a, but since we're talking about range is y values, we're going to say it's y less than or equal to minus a. This is the range of the inverse function. Make sense? So domain of the original function is the range of the inverse function. Range of the original function is the domain of the inverse function. The set of values is the same. The symbol is going to change. For domain, we use x. For range, we use y, because domain is x values, range is y values. Okay. Part C. Now it says, given that a equals 7/2, solve this equation, g f of x equals 0. Now, what were the two functions that we had? F of x equals x plus a whole squared minus a. And the domain of this function was x less than or equal to minus a. And the other function was g of x equal to 2x minus 1. And it was valid for all real numbers. Okay. Now, the equation that we need to solve is g f of x equals 0. For that, first of all, they've given us the value of a. So it becomes x plus 7/2 whole squared minus 7/2. And the domain is x less than or equal to minus 7/2. That's the function f of x. And g of x is this. We just have to solve this equation. Now, g f of x equal to 0. G f of x, what does that mean? That means g of f of x that equals 0. Inside g, you have to input f. So it becomes g of x plus 7/2 whole squared minus 7/2. In the g function, wherever you've got x, you're going to replace that with this whole thing. In the g function, x is going to be replaced with this whole thing. This x, you're going to input this. And then just solve that equation. Now, what do you get from this? Two into x plus 7/2 whole squared minus 7/2 minus 1 equal to 0. This is the equation that we need to solve now and find the values of x. Now, one possibility could be to expand this square and then solve it like a normal quadratic equation using quadratic formula or factorization. In this case, I think factorization is not going to be possible. Using quadratic formula, you'll have to do that. One or the other possibility, the quicker way of doing this would be to leave it like this and just simplify, or in fact, you might not even need to do that. Yeah, you can just leave it like this. So on the left side, you have x plus 7/2 whole squared minus 7/2. Take 1 to the other side. What does that become? 1 plus 1. This 2 that you have, this goes to the other side, gets divided, and you're left with 1/2 there. Now take this 7/2 to the other side. 7/2 plus 1/2, that's 8/2, which is 4. Now you take square root on both sides. When you take square root, remember, plus minus. So you have x plus 7/2 equals plus minus 2. On the left side, the square gets eliminated. On the right side, the square root of 4 is 2, and you have plus minus 2. That gives you two equations, x plus 7/2 equal to 2, or x plus 7/2 equal to minus 2. And you get x equal to 2 minus 7/2, which is minus 3/2. And x equal to minus 2 minus 7/2, which is minus 11/2. These are the two values that we're getting, but since we're getting multiple answers, we should check if both of them are possible. What was the domain? The domain was x less than or equal to minus 7/2. Minus 7/2 is minus 3.5. So the values of x, remember, it's a composite function, right? It's a composite function. The composite function is g f of x. the domain of the composite function is the domain of the inner function. So this function g f of x, this also has this domain. Inner function is f here. Domain of this function is also minus 7/2. X less than equal to minus 7/2. So the values of x that you get, they have to be less than equal to minus 7/2. Minus 3/2 does not satisfy that condition. So we would have to ignore this possibility. We would say this is not possible. The only possible answer is x equals minus 11/2. That's the only possible answer. Okay, and that's the result that we were looking for here. That was question number 8. Okay, I hope that makes sense. Now we'll have a break of 10 minutes before the M1 class. For those of you who are taking that as well, we resume at, we start the M1 class at 7:20 inshallah. And the P1 class, the last 3 questions, we're going to do them at 9:30 p.m. Pakistan time. Tonight, inshallah, we will complete that paper. From tomorrow onward, we are going to try and start a bit early. What I'll do is I can start the setup and everything of the class a bit early so that around 5, we can hopefully get started already. So let's hope the time is better managed from tomorrow. But for today, we have the next part of this class at 9:30 inshallah. All right. I hope this was helpful. If you have any quick questions, you can ask them verbally quickly in 1 minute if you have any. Otherwise, we have a break. You can ask questions in the second part of this class tonight as well. Joseph, I'll let you know. I've seen your message. I'll let you know as well. Okay. All right, good. So I'll see you in the next part tonight at 9:30 p.m. Allah Hafiz.